All right, this is a calculator area volume free response, and this is how they've been trending more the last few years. They'll have, instead of having find the area, find the volume, find a volume of rotation, they have thrown in different questions so that one of the questions is find the area, one of the questions is find a volume, but one of the questions is something a little bit weird, and we're going to kind of see how that looks here. All right. So, let f and g be these functions. Because this is a calculator question, they don't make it clear which one's which, but what you can do is you graph them, and once you've graphed them, you can say, okay, the blue one is 1 plus x, that one, and so this one is f of x, and this is g of x, and we can tell that just by looking at it on the calculator and seeing which one matches up with our blue equation and our red equation. We need to find the sum of the areas of the regions of R and S. So we need to find this area plus this area. The first thing we need to do is we need to find this intersection. They've already given us this intersection and this intersection, but we need to find our intersection so when we graph them, we're going to find the intersect, second calc intersect, enter. We don't want our guess to show up right there. We want our guess to be right around here. Press enter one more time. And so the intersection is at x equals 1.0328. So the area of R is going to be the integral from 0 to 1.0328 of the top one minus the bottom one, which is going to be g of x minus f of x. Let's do that. So we've got the integral from 0 to 1.0328 of, in this case, it's y2 minus y1. You can do this in your calculator very easily just by going to the variables button. The variables button is right next to clear. Go to y variables, and we're using y1 dx. That's the first integral, plus the area of S is going to be the integral from 1.0328 to 2 of, and now it's going to be f of x minus g of x. So in my calculator, that is the variables y1 minus, again, where we get to it is variables, y variables, function y2 dx. And we'll let the calculator calculate it for us. It's 2.004. Now, putting 2.004 isn't good enough. We actually need to write down this integral that we did here. So it's the integral from 0 to 1.0328 of g of x minus f of x dx plus the integral from 1.0328 to 2 of f of x minus g of x. Notice that usually you do not lose any points for not putting the dx, and if I don't put the dx here, I won't lose any points on the AP exam, but I need the dx here. This has to be here because it ends the integral, and if you didn't do this, this integral would be inside of this other integral. You'd be doing the integral of an integral, which wouldn't give you the same answer. So if you don't put this dx here, you would lose that point. This dx I should put, but I wouldn't lose points for leaving that. Okay, next, region S is the base of a solid whose cross-section is perpendicular to the x-axis, so we're going to be cutting it perpendicular to the x-axis, and that makes a square. Find the volume of the solid. So there's a bunch of squares sticking out here, and so it looks something like this. We're adding up all these squares as we go along, so this is using our formula, volume equals the integral of area at each x. So we just have to find the area at each x value, and a of x here will equal the area of this square, which is just side squared, and our side is going to be this length. The way you find a vertical length is you just do the y value minus the y value. This y value is changing, but it's always f of x, so s equals f of x minus g of x. It's the top one minus the bottom one. And that's what the side length is, and because it's a square, the other side will also be f of x minus g of x because they have to be the same lengths. So our integral is the integral from 1.0328 to 2 of f of x minus g of x squared. And I guess we can do that. So it is the integral from, I'm just going to use this one from above and delete this original integral. And it's y1 minus y2 squared. That should be our integral, and it's 1.28. I guess I should have put my answer to this one above. This was 2.004. This is 1.283. Okay. And the last question. This is where things have been a little bit different. They've been asking questions that aren't necessarily area or volume questions. It says h is the vertical distance between the graphs of f and g in region S. So h is a new function. It's the vertical distance between f and g in S. Find the rate at which h changes with respect to x when x is 1.8. So this is asking for the dh dx. It wants to find the derivative of h with respect to x when x is 1.8. And so we need a function for h. Well, h is the vertical distance from here to here. That's just f of x minus g of x. That's the vertical distance, and so all it's asking you to do is find the derivative of f of x minus g of x. So this is a calculator problem. So all we have to do is press math, and instead of doing the integral, we're actually doing the derivative here of y1, which is f of x, minus y2 at x equals 1.8, and the calculator can do a derivative at a point. Let's remember we can do that. And so at x equals 1.8, I guess I should label things. H of x equals this. H prime of 1.8 equals, and this is all we have to do because you can do h prime of 1.8 in the calculator. It's negative 3.812, or they would have given you credit for negative 3.811. So that's it. Hopefully that's helpful.